Now we'll get into pH, acids, base, and salts. Alright, pH is a scale. And pH, P, means the negative log, and this is a mathematical function, a logarithmic function. You don't have to solve them in this class, don't worry. You just have to understand what the value itself means. So this is the negative log of the concentration of hydrogen ions in a solution. So these brackets mean concentration, this plus indicates that it's in ions, and this H means it's hydrogen. So it's hydrogen ions, concentration of them, and take the negative log of that number will give you your pH. So this is a scale from 0 to 14, 0 being on the acidic side. You hit 7 at neutral, and you hit 14, and we call this alkaline or basic. We'll use the term alkaline really whenever we talk about inside our body. Whenever we say bases, we're more saying, you do say basic solutions, but we think of bases as things, but you can use the term interchangeably, but you'll probably hear him say alkaline more. Okay. Some examples. Let's do some examples of some acids. So 2, a pH of 2, stomach acid. pH of milk is like 6. I'm looking this up right now. 6.7 to 6.9. Water is supposed to be neutral. And I say supposed to because we don't have pure water. Who knows what's in our water? And then some basic stuff. You have stuff like sodium hydroxide, which has OH. And when you get in the strong base, this is where you get up to those 14s. Okay. So this is an important value for the human body, that's stomach acid. Another important value, this range, 7.35 to 7.45. That's our blood pH homeostatic range. Okay, so we have this range between 7.35 to 7.45. So we're slightly alkaline or slightly basic. And we'll talk about how we maintain that blood pH because we're constantly eating. Our diet is very high in acids, so we'll see some mechanisms that we use to prevent going into acidosis. Alright, so pH, description of the level of acidity or alkalinity. It's expressed on a scale, refers to the hydrogen ions in the solution. The lower the pH, so the lower the number, the higher the acidity. The body has different pHs throughout the body has different pH levels throughout it. So we saw this blood pH example, and then we saw this stomach acid pH example. Let's differentiate acids and bases. So acids, and then we'll probably, we'll stop after that and do another video. So acids and bases. So there's a few different ways to look at acids and bases, a few definitions. The ones we're going to use are proton donors for an acid. Bases are going to be proton acceptors. So you can't just think, oh, a plus means acid and a negative means base. That's not the best way to look at that. Because what we need to remember is acids are going to dissociate. So acids dissociate to give hydrogen ions. So you do get this positive charge, that's from the hydrogen ion. But let's draw an example of something like an amino acid, okay? And we'll see where this might get a little confusing. I don't know how detailed this will be in this class, but if you're taking organic or something, this will definitely help you. So for an amino acid, you have this amino group here. You have an R group coming over here. You have an H. And don't worry about this. Please, please, please don't focus too much on this right now. That's just a setup. What I really want to show you is this over here. So you have this COOH. This is a carbon right there. That's an O and OH. This is called a carboxylic acid. So how this is an acid, if you looked at this amino acid and it didn't have this H, okay, because it went into solution and dissociated, then you'd have two different molecules. We'd have, remember, acids dissociate in solution. So you'd have this, you'd have your R, and again, please don't get too hung up on what I just drew. But then you'd have this O here with this negative charge. So to me, whenever I was first learning organic and whatnot, I was saying, oh, this must be a base because this is negative. But you have to remember that this gave away its proton. So even though this is a negative, this has a negative charge, it's because it gave away or it donated its protons. So when you're looking at it, something, if it gave away a proton, if it's increasing the concentration of hydrogen ions in the solution, then it's going to decrease the pH and it's going to make it more acidic. Again, if this organic structure went way over your head, just forget about it. Don't worry about it. All you need to know, acids are going to dissociate, which you should be able to remember that from our discussion of dissociation versus dissolving. But the big thing to take away, acids are proton donors. Bases, proton acceptors. These are important. Acids and bases are important because whenever you have these charges, or whenever you create a bunch of protons, these hydrogen ions, you change the pH, and that can throw you out of homeostasis. So acids and bases are super important in affecting homeostasis in the body. When we talk about lactic acid, if you've ever been lifting weights and you feel like you just can't lift anymore, that's because the lactic acid has made the pH of your muscles way too low, way too acidic, and it literally forces you to stop exercising. Okay, that's a little rant there. So that's acids, bases. Let's do salts next. So acids are going to increase our hydrogen ion concentration. Bases are going to increase our hydroxyl ion concentration, which is and let me do this on another page. So if we have a base will increase the concentration of hydroxide ions or hydroxyl ions in solution. And the way that works is if you have this water molecule, OH plus, whatever this base is, remember, a base is a proton acceptor. Another name for a proton is a hydrogen ion, just so you know. This is a proton right here. So what this base can do is this base is a proton acceptor, so it can take this proton. So now you have BH plus OH minus. So that's where you get this increase of hydroxide ions. And whenever you increase the concentration of OH minus, you decrease the concentration of H plus, which means you increase your pH. Okay, so again, I like to go really big into detail because even though this might be a little more focused on orgo than you need, I think that having the general well-rounded knowledge of it all is going to help solidify it in your mind the most. But if that's too much for you, if you haven't taken organic yet, what we need to get out of this, acids dissociate in solution, increase hydrogen ion concentration, decrease pH. Bases, proton acceptors, increase pH. Salts, these are going to dissociate into things other than hydrogen and hydroxide ions. So instead of affecting H plus and OH minus, these are going to affect other things. So a salt is going to dissociate in the body, and when it dissociates into ions. So now we have an Na plus and a Cl minus. These kind of ions don't have an effect on the pH like hydrogen ions do. So just because these dissociate and we have this positive here and this negative here, doesn't mean it's really going to throw us out of our pH range. Okay, let me think of another salt really quick. So just so that you see something, because just so you see something other than table salt, because you always see table salt. Here's another one that's like, let's just say sodium. We'll do sodium hyperchlorite, so NaClO. If this went into your body, it would dissociate into an Na ion plus a ClO minus ion. So dissociation, these are salts. The definition of a salt. Dissociation to ions other than hydroxide and hydrogen. Alright, cool. So that's where we'll stop this video, and next we'll pick up with the organic molecules.